perhaps more importantly, through the ways in which they differ. This notion of holding up a mirror to the past works both ways. The present can also illuminate the past. As Mark Bloch pointed out, history is always written from the perspective of the present, based on our current interests and the questions that we are grappling with. Otherwise, why would so many works have been published recently on the history of cultural exchanges and intermixing of communities, if not to explain our current preoccupation with them? In the history of science, as in social history, historians do not seek to provide solutions by highlighting similarities and differences, but by revealing the issues currently being debated. Let's add that those who wish to reflect on the history of the biological sciences can start only from their own knowledge of science, acquired in junior high or high school, to which information from the media on the current state of science is subsequently added. This is not, however, the case for physics and mathematics, where the complexity of current research and the sophistication of the mathematical tools needed to understand it often lead to teaching these sciences in an outdated way. One's current understanding of the subject is therefore the starting point and point of reference for anyone who is not familiar with the history of biology. To fulfill our objective, I have chosen to present this history in chronological order. I have broken it up into periods, some of which roughly correspond to centuries. Without fully subscribing to Michel Foucault's view that all scientists are prisoners of the time in which they live and are limited to the views and tools that it provides them, as was reiterated by François Jacob in The Logic of Life, I nonetheless believe that the historical context is crucial. Moreover, there is a dynamic to scientific discovery that only a chronological approach allows you to get at. For each period, Antiquity, the Middle Ages, the Arab-Muslim world, the Renaissance, and so on, the chapter devoted to it is divided into 3 parts. The first, the facts, is a description of the changes that occurred in our understanding of biology and medicine during the period in question. The 2 sections that follow seek to shine a light on the connections that exist between the past and the present. Here we can break free from the straitjacket of chronology and take a more comparative approach. Historical overview provides a more in-depth look at certain ideas, lines of questioning, and models that were pivotal both to the period being examined and to contemporary biology, and which were briefly covered in the facts section. These themes are selected with an eye to the present, or more precisely, what they could add to our modern-day understanding, or episteme, as Michel Foucault was fond of calling it, of biology. Themes are introduced in the context of the period in which the relevant ideas and questions received the most attention. The final section, Contemporary Relevance, seeks to compare different periods more directly by pointing out similarities and differences between the past and the present. This is a history of biological thought, or what is known as a conceptual history. Developments in techniques and descriptions of experiments and experimental systems have their place, as do social and cultural history, because science is not separate from them. However, providing only the social, economic, and cultural context does not on its own constitute a history of science. Many recent works on the history of science, and an even greater number of articles, are disappointing for scientifically minded readers in this regard. They describe the social and cultural context in which scientific knowledge develops very well, better than older works, but often have nothing to say about the substance that makes up this knowledge, or the theories and models that scientists are working on. The authors of these works sometimes seem to believe that readers are familiar with these topics and don't need to be reminded of them. More often, reading them reveals that the authors themselves do not have a solid grasp of the subject matter and, more worryingly, do not perceive this lack of knowledge to be an impediment to completing the project. This lack of understanding can even be justified or claimed as a badge of honor, as providing the observer with some distance from the subject being studied. The drawbacks of covering such a long period of time can be compensated for by the advantages of this more comprehensive approach, which allows one to delve more deeply into aspects of knowledge theory that have long occupied the thoughts of philosophers of science and are still being debated to this day. In the case of life sciences, these include the important but also difficult relationships with other disciplines, such as mathematics and physics, and the continuity-discontinuity dialectic in the development of scientific knowledge. Most historians highlight changes, breaks, and even revolutions in the development of scientific knowledge. Controversies, which represent points where science diverges, are also